and welcome to the third video of the ISTQB Certified Tester Foundation Level Preparation course. My name is Dmitry, and I'm a Creative Manager at Exactpro. Today, we will cover Chapter 3, Static Testing. As you already know from previous chapters, testing objectives include finding defects and assessing quality. Static testing and dynamic testing are the two approaches that can be used to achieve that. The focus for this video is going to be on static testing. Dynamic testing will be discussed in Chapter 4, so please stay tuned. What is the difference between static and dynamic testing? Dynamic testing is the kind of testing that involves execution of the test item. With dynamic testing methods, software is executed using input values. The output is then compared to what is expected, and the results are analyzed. Static testing is a type of testing that does not involve the execution of a test item. During static testing, the software is not executed, but examined manually or with tools. This process is all about reviewing the software code and requirements. There are two types of static testing: review and static analysis. Review is a type of static testing in which a work product or a process is evaluated by one or more individuals to detect defects or to provide improvements. Static analysis is the process of evaluating a component or a system without executing it, based on its form, structure, content, or documentation. They both assess the code or other work products being tested without actually executing the code or work product. The difference between them is that review is a manual examination of work products, but static analysis uses tools to evaluate the code. Static analysis can be applied efficiently to any work product with a formal structure, typically code or models, and there are appropriate static analysis tools for that. Static analysis can even be done by tools that evaluate work products written in natural language, such as requirements. For example, you can check the spelling, grammar, and readability. Static analysis tools are typically used by developers before and sometimes during component and integration testing. These tools demonstrate structural attributes, depictions of control flows, data relationships, and the number of distinct paths from one line of code to another. Modern integrated development environments, IDEs, can be considered static analysis tools, since they build a symbol table, check for coding standards compliance, and identify issues. For example, unreachable code, wrong usage of standard APIs, conditions that are always true or false. Checking for adherence to coding standards is paramount. When we evaluate compliance, we need to define or adapt a standard or a set of rules. The tools called linters help a lot. They check for code compliance automatically. And why is automation important here? There are three main reasons for that. 1. The number of rules in coding standards is usually so large that nobody can remember them all. 2. It is very hard for a human to check some context-sensitive rules that demand simultaneous reviews of several files. And 3. If people spend too much time checking coding standards in reviews, it distracts them from looking for defects. Okay, let's review another question. What can be tested with static testing? And the answer is almost anything that is written or typed can. Let's take a closer look. Work products that can be examined by static testing are 1. Specifications, including business requirements, functional requirements, and security requirements. 2. Epics, user stories, and acceptance criteria. 3. Architecture and design specifications. 4. Code. 5. Testware, including test plans, test cases, test procedures, and automated test scripts. 6. User guidelines. 7. Web pages. 8. Contracts, project plans, schedules, and budget planning. 9. Configuration, setup, and infrastructure setup. 10. Models, such as activity diagrams, which may be used for model-based testing. Static testing techniques provide a variety of benefits. Static testing usually begins early in the lifecycle, providing timely feedback on quality issues. Detecting defects from the very start keeps the rework costs relatively low. And since the correction effort is reduced, the development productivity figures are likely to increase. Defects found and fixed early won't be introduced to the code, which means that they will not be executed and will not cause errors. To avoid discrepancies in the requirements, a series of meetings might be organized with the software development team to ensure that all the components of the build are present and aligned with the set requirements. The evaluation by a team has the additional advantage because there is an exchange of information between the participants, and that is quite essential to the process. Let's say some of the key players get sick or leave the company during the final stages of development. Their colleagues, familiar with their work, can still deliver the project on time. And there are even more benefits. Detecting and correcting defects more efficiently because it's done prior to dynamic testing execution. Identifying defects which are not easily found by dynamic testing. Preventing defects in design or coding by uncovering inconsistencies, ambiguities, contradictions, omissions, inaccuracies, and redundancies in requirements. Increasing development productivity due to improved design and more maintainable code. Reducing cost and time of development. Reducing cost and time of testing. Reducing total cost of quality over the software's lifetime due to fewer failures later in the life cycle or after delivery into operation. And improving communication between team members in the course of participating in reviews. Let's compare static and dynamic testing. In the process of dynamic testing, we launch the product and see that something is being performed incorrectly, or it is not displayed correctly. And this is a failure. Again, in contrast to dynamic testing, static tests do not run the product at all. The program code is not executed at this moment. Static testing does not involve the execution of the software. We not only analyze the constituent part of the code, but we also analyze the project as a whole. As we can see, static testing can be applied to almost any type of work product. To sum it all up, static and dynamic testing complement each other by finding different types of issues. Static testing finds defects. Dynamic testing finds failures. There is no question of comparing static to dynamic testing to decide which one is better. Both testing types can have the same objectives, such as providing the quality assessment of the work products and identifying defects as early as possible. Again, the main distinction is that static testing finds defects in the work product directly rather than identifying failures caused by defects when the software is run. A defect can reside in a work product for a very long time without causing a failure. The path where the defect lies may be rarely exercised or hard to reach, so it will not be easy to construct and execute a dynamic test that encounters it. Static testing may be able to find the defect with much less effort. Another distinction is that static testing can be used to improve the consistency and internal quality of work products, while dynamic testing typically focuses on externally visible behaviors. Usually, the dynamic testing prevails, but the time spent on the static testing pays off and saves time and effort for dynamic testing. Compared with dynamic testing, typical defects that are easier and cheaper to find and fix through the static testing include requirement defects, for example, inconsistencies, ambiguities, contradictions, omissions, inaccuracies, and redundancies. Design defects, for example, inefficient algorithms or database structures, high coupling, low cohesion. Coding defects, for example, variables with unreachable values, variables that are declared but never used, unreachable code, duplicate code. Deviations from standards, lack of adherence to coding standards. Incorrect interface specifications, for example, different units of measurement used by the calling system than by the called system. Security vulnerabilities, for example, susceptibility to buffer overflows, and gaps or inaccuracies in test basis traceability or coverage, for example, missing tests for an acceptance criterion. Static reviews range from very informal to formal. An informal review process is easy. You just come up to your colleague and say, "Hey, I have written some code. Can you look at it, please?" You probably create a corresponding task in Jira, Redmine, or whatever the issue tracker your company uses. A formal review is much more complicated. Formal review is a type of review that follows a defined process with a formally documented output. For instance, we need to review a very important document or a piece of code. Formal reviews are characterized by team participation, documented results of the review, and documented procedures for conducting the review. In this case, there are certain phases we need to go through. Step number 1 is planning. The goals of this phase are defining the scope, estimating time and effort, selecting the personnel and allocating roles, defining entry and exit criteria, and checking entry criteria. Then comes step number 2, initiate review. Its objectives include distributing the documents, explaining the scope, objectives, process, roles, and documents to the participants. After that comes individual review or individual preparation. Here we review the work product and note potential defects, questions, and comments. Then we have issue communication and analysis. Its goals are communicating and analyzing potential defects, assigning ownership and status to them, evaluating and documenting quality characteristics, evaluating the review findings against the exit criteria to make a review decision. And finally, there is fixing and reporting. The objectives we have to meet here are creating defects found, fixing defects found, communicating defects, recording updated statuses of defects, potentially including the agreement of the comment originator, gathering metrics, checking that exit criteria are met, and accepting the work product. The results of a work product review may vary, depending on the review type and formality. And that's not all. The formal review is usually done by a group of people with defined responsibilities. We will need the author. Author creates the work product under review and also fixes defects in the work product after the review, if necessary, of course. Management is responsible for review planning, assigning staff, budget, and time, monitoring ongoing cost effectiveness, execution of control decisions in the event of inadequate outcomes. Moderator or facilitator ensures effective running of review meetings, mediating between various points of view. This is often the person upon whom the success of the review depends. Then we have review leader, who decides who will be involved in the review and organizes the time and place of the review meeting. Leader has overall responsibility for the review. We also have reviewers. They are people who take part in the review meeting to identify potential defects in the work product under review. They may represent different perspectives, for example, testers, developers, users, operators, business analysts, and usability experts, and so on. And then we have a scribe. He records each defect mentioned as well as the improvement suggestions. In some review types, one person may play more than one role, and the actions associated with each role may also vary based on the review type. In addition, with the advent of tools to support the review process, especially the logging of defects, open points, and decisions, there is often no need for a scribe. This sounds a bit too much, so let's take a step back and start with the most casual type, and then work our way up the formality of the review chain. It's a flexible process, and the team chooses how strict the review for this code should be. We have informal reviews, also known as buddy checks, pairings, and peer reviews. They're basically inexpensive ways to get some benefit. It's a type of review that does not follow a defined process and has no formally documented output. These types of reviews may be performed by a colleague, which means that the usefulness will depend on the skills of your peers. On the bright side, all documentation is optional, so you could save some time, which makes it a perfect companion for agile development. Walkthrough is a type of review in which an author leads members of the review through a work product, and the members ask questions and make comments about possible issues. And here we up the formality a notch. First of all, it comes in the form of a meeting. It's led by an author, and the scribe is mandatory. And even though the individual preparation and checklists are optional, the meeting still produces defect logs and reports. Other than finding bugs, this type of review is all about exchanging ideas about techniques, achieving consensus, and participant training. And then we have technical review. It's a formal review by technical experts that examine the quality of a work product and identify discrepancies from specifications and standards. Again, the protocol becomes stricter. First of all, the reviewers who should be experts in this or neighboring disciplines must go through individual preparation. The meeting itself is optional, but if it does happen, it should be led by a trained facilitator with a scribe present. Checklists are optional, but the defect logs and review reports should be produced. Finding defects is still the key, but there are some additional possible benefits as well, like building confidence in the work product, motivating authors to improve, and considering alternative implementations. And finally, inspections. Inspection is the most formal review type used to identify issues in a work product, which provides measurement to improve the new process and the software development process. Everything we have listed before applies here, with addition of entry and exit criteria, mandatory meeting, and checklists. As a result, metrics are collected and used to improve the entire software development process. Needless to say, all four types serve their primary objective. The bugs get raised and then fixed. This sort of developers' cooperation promotes the right approach to code ownership and accountability. It also helps to bring newcomers into a fold through onboarding and education. Reviews can be used for various purposes. One of the main objectives is to uncover defects. All review types can aid in defect detection, and the selected review type should be based on the needs of the project, available resources, product type and risks, business domain, and company culture, among other selection criteria. A single work product may be the subject of more than one type of review. If more than one type of review is used, the order may vary. For example, an informal review may be carried out before a technical review to ensure the work product is ready for a technical review. The formality of a review process is related to factors such as software development lifecycle model, the maturity of development process, the complexity of the work product to be reviewed, legal or regulatory requirements, and the need for an audit trail. During the individual review, there are a number of review techniques that can be applied to uncover defects. The effectiveness of the techniques may differ depending on the type of review used. Let's go over them one by one. Ad hoc, a review technique performed informally without a structured process. Here, reviewers are provided with little or no guidance on how these tasks should be performed. They often read the work product, logging issues as they encounter them. This technique is highly dependent on reviewer's skill. Ad hoc testing is the least formal test method of review. Since there are no written test cases, it has been criticized because it's not structured, and hence defects found using this method may be harder to reproduce. However, the strength of ad hoc testing is that important defects can be found quickly. Checklist-based, a review technique guided by a list of questions or required attributes. A review checklist consists of a question set based on potential defects, which may be derived from experience. Checklists should be specific and should be regularly updated. They can also focus on checking specific aspects, such as the type of defect that occurred earlier. Here, the main advantage is the systematic coverage of typical defect types. A checklist-based review is a systematic technique whereby the reviewers detect issues based on checklists that are distributed at review initiation by the facilitator. This review is more effective because there are helpful instructions of what to look for. Scenarios and dry runs. This technique provides better guidelines on how to identify specific defect types because it is based on expected usage. Scenario-based review is a review technique in which a work product is evaluated to determine its ability to address specific scenarios. In scenario-based reviews, reviewers are provided with structured guidelines on how to read through the work product. Going through the scenario or a dry run is a rehearsal for the system. When using the scenario, we act out realistic ways of using the system and check whether it will meet the needs and expectations of users. Perspective-based and role-based. Perspective-based reading is a review technique in which a work product is evaluated from the perspective of different stakeholders, with the purpose to derive other work products. Here, the reviewers take on different stakeholders' viewpoints and roles. A crucial success factor in this technique is including and weighing the opinions based on the severity and probability of risks. There is no single right way to conduct reviews, but when reviewers look at the work product from different angles, using scenarios, checklists, and perspectives, then the best results can be achieved. The most common reasons for failure in reviews are due to the lack of organization, as well as people-related factors. In addition, in order to have a successful review, the appropriate type of review and the technique should be chosen. Organizational success factors for review include: each review has clear objectives defined during review planning and used as measurable exit criteria. Review types are suitable to achieve the objectives and are appropriate to the type and level of software work products and participants. Any review techniques used, such as checklist-based or role-based reviewing, are suitable for effective defect identification in the work product to be reviewed. Any checklists used address the main risks and are up to date. Large documents are written and reviewed in small chunks, so that the quality control is exercised by providing authors early and frequent feedback on defects. Participants should have adequate time to prepare. Reviews are scheduled with adequate notice, and management should support the review process. Reviews are integrated in the company's quality and test policies. People-related success factors for reviews include: the right people should be involved to meet the review objectives. Testers are seen as valued reviewers who contribute to the review and learn about the work product, which enables them to prepare more effective tests and to prepare those tests in advance. Participants dedicate adequate time and attention to detail. Again, reviews are conducted in small chunks, so that reviewers do not lose concentration during individual reviews and the review meeting. Defects found are acknowledged, appreciated, and handled objectively. The meeting is well managed, so that participants consider it a valuable use of their time. The review is conducted in an atmosphere of trust. Participants avoid body language and behaviors that might indicate boredom or hostility. Adequate training is provided especially for more formal review types, such as inspections. A culture of learning and process improvement is promoted. This concludes today's video. In the next video, we will concentrate on Chapter 4 called Test Techniques. See you then.